So now we are going to start the scientific session. Briefly, the agenda for today. We have today's agenda. Today we are going to start by the poultry health topics. There will be two presentations by Dr. Sjaak. The first one will be about infectious bronchitis, and the second one will be about infectious Bursal disease, updates about epidemiology and infection and control measures. Then we will move, after a short break for 30 minutes, we will move to the Dr. Sjaak about the biosecurity and intensive poultry production. Then again we'll have the lunch break. Then we'll have a speech by the ARTAT Center. Will be after the lunch. Then we have a short break again. We have important topic we will discuss about the how to reduce salmonella colonization in poultry farms, control salmonella at farm level by Dr. Bursal, who will join us shortly. And then we'll have the how to diagnose or make the right diagnosis, the best approaches to diagnose poultry pathogens by Dr. Benyu. This will be the final topic or the final presentation, then the closing of the day. So I'd like to invite you. So the first topic we are going to discuss with Dr. Sjaak. Okay, Dr. Please. So Dr. Sjaak is the senior scientist and immunologist in the Royal GD Deventer, and he is also a professor of integral poultry health in ARTAT University. Dr. Sjaak is now the head or the president of the World Veterinary Poultry Association, the president of WVPA. Dr. Sjaak's passion is in avian viruses, particularly infectious bronchitis, long-term history of publications, and he is responsible for in Royal GD for all the accreditation steps for the proficiency testing and accreditation of labs, providing consultation for different parts of the business or of the industry, for the hatcheries, for the farms, for the slaughterhouses. So we have two interesting topics about infectious bronchitis and infectious Bursal disease. So the stage is yours.
We have a lot of different strains of IBV, partly a result of drift, continuous amount of mutations. Sometimes we have recombinations. They are not that common, but some strains are the result of recombination. And sometimes we think we have an introduction from a coronavirus from another species, which is able to maintain in poultry. We don't have them that much, but some of them we think are the result of this interspecies transmission. But in reality, if you get a new strain in the Middle East, it might just be an introduction from another area. And most strains come from somewhere else. They are not mutated in your own. If this works better, I hope. Okay. So, reality, it might be that you just have a strain from another area. Well, for coding IV strains, that has been. Okay. Yes. The coding of IV strains in the past was a big headache. Many different names for the same virus, or sometimes the same name for different viruses. But now this is the gold standard. A paper from 2016. It is very helpful for coding different IV strains. But as you know, IV is always on the move. So in this paper from 2016, we had a certain number of genotype and lineages. And now we already have new types added. It doesn't say there are always more IV strains, some also disappear, but it's a continuous story. But if you look for the Middle East, then the strains that you see most at the moment is I guess the 793 and the family 2. But not just these types, you also have the QX, Q1, Massachusetts, D274 is sometimes also recombinant. so not all strains are able to do it. The enteric tract is, for me, still a matter of discussion. IB can replicate in the enteric tract, but damage, clinical damage is, for me, still, in many cases you don't see a lot of damage. But the propheticulus, I'm not sure yet. I don't think the science is good enough yet. Muscle damage, I know it's in the literature, please delete it. IBV does not damage the muscles. What you will see though is depend very much on the other co-infections or maybe secondary infections. There's a long list of IBV with other respiratory pathogens that can really increase the damage a lot. Also immunosuppression, like Ebola disease, chikungunya, Marex, can have a major influence on the outcome of IBV infections. Then in broilers, it can start with a respiratory acute disease. Also the feed intake and growth go down. The respiratory signs might be clear, they might be mild. You just have big males that die. You might have swollen head syndrome, you have a lot of variability. That also depends on the maybe other infections that are present at the same time, or the quality of the climate and the influence of potential immunosuppression. Mortality by the respiratory tract by IB is very uncommon, and then you need the bacteria, like coli. Nephritis, you can see it. I come back to that in a few slides. So this is I guess one of the main reasons for mortality by coli is because, mortality after IB infection is because coli comes in. And this is a classical study from Jim Cook, where they saw that if coli comes in a bird that has been infected by IB, there can be a lot of mortality. If the bird had been protected by vaccination against IB, there was no damage by coli. So protection of IB is important to lower the increase, or to lower the influence of coli. Another example of co-infection, which is very important, is a combination of a low power H9N2 with IB. H9N2 alone in a flock. In good conditions, you might, it's a mild disease. If you combine it with IB, you can have a clearly sick flock with also mortality. And you can see that if you see this kind of cause in the wrong eye, it's not a proof of H9N2 together with IB, but you should certainly check for the presence of H9N2. So if you can protect against IB, you can also lower the damage by H9N2. But it's not just a combination of H9N2 with IB that's giving more problems. This is another example of Newcastle, in this case a vaccine, around the time of the H9N2 infection. And you can also see the mortality with the combination of, basically two mild viruses is giving much more damage than if you have the Newcastle vaccination alone or the H9N2 alone. An example of the influence of the immunosuppression, in this case chikungunya virus. If there was immunosuppression up to 40, 50%. Egg quality goes down. You have a loss of quality of the shells, the color and the strength, more cracks, more sandpaper eggs. The albumin is getting thinner, and also the hatchability goes down. This is all the result of an acute infection during lay. You could also have false layers, but that's not the result of an infection during lay, but it was an infection in the first few weeks of life. And if you have this acute infection during lay, if you do a post-mortem, you might see about nothing until, well, up to very severe damage to the oviduct and ovary. That can be also that the ovary, I don't know if you can see it over here, but it's a kind of, the complete ovary is also, well, degenerated and the yolk is through the whole body. It looks like cholecystinitis, but it's not due to coli, it's just the IV. These birds don't die unless they get a coli as well, and then they are dead in a few hours. Nephritis is very, very uncommon in layers and breeders. There might still be some damage, but you don't see it at the post-mortem. It's much milder. If you don't have a drop in egg production, but just a very low peak in production, it might be the result of a very early infection with a pathogenic strain. And these infections in the first 1-2 weeks of life can damage the oviduct for life, but the ovary, the hormones are still working. So these false layers are fully active. They act like they are laying an egg every day. All the hormones are there, but no eggs. So you can have a peak in egg production of 30%, or 80 or 90. You can have 1% false layers up to 80%. It really depends on which strain, which age, in combination with the lack of maternal-derived antibodies. So you don't find the virus anymore. It's too long ago. So the clinical signs due to IB are highly variable. Many factors play a role. So without proper diagnostics, you don't know what you're dealing with. And please, diagnostics for IBV also includes a check for the other pathogens. And so, if we find an IB strain, well, we also have to know which one, else it's hard to do anything. Well, we have different typing systems, but in reality, modern time we go for PCR because that's affordable and relatively fast. Well, we have two major approaches for detecting IBV and typing it. One is that you have let's say a general PCR for the S1 gene, and then the spike, the most dominant gene or protein for protection, and also for variation between strains. If this PCR is positive, then you're going for sequencing. And with sequencing, you get detailed information about the strain that's in your flock. And you can see whether it's a field strain or a vaccine, and of which genotype. So, very good method, but with sequencing, with normal sequencing, if you have combinations of infections, you might only find the dominant strain. But that's most likely the most important strain, but okay, you might not see the other ones. The second approach, or the other approach, is to use genotype-specific PCRs, a panel. So, let's say a panel with, I don't know, QX, separately, variant 2, Massachusetts, it's a whole panel. And for each genotype, you get a result. Good method. However, it cannot discriminate between vaccines and the field strain of the same strain. It's separately yes or no, or QX or variant 2. So if you have been vaccinated in these strains as well, you don't know whether you're detecting the vaccine or field strain. On the other hand, you do get CT values. That's an indication how much virus is there, and that's also informative. And if you have mixed infections, these kind of tests have less problems with showing all the strains. So, two different methods, both with vaccines, for example. Another example is on the right, where we see that the QX virus, well, we see different clusters in different years. This is not drift, because the difference with the old-fashioned strain is still the same. So sometimes a subclade comes up and disappears again. So sequencing is very informative. We also have antibody detection, very useful, but not easy. The variability in the antibody response and the field conditions is high due to all the variables. When do you vaccinate? What level of derived antibodies? Quality of the application, which vaccine applied at which age, what kind of bird, intervals, it's a lot of variability. So interpretation of serology, well, when there are so many variables, there are no simple rules. Although simple rules are applied by some ELISA producers that say, if you do this, you get this titer. But if you look at the range of these titers, it's going from very low to very high. So it's not, I don't consider it to be very good. If you can solve this partly by using sequential data, and if you have a layer flock of breeders, and you have paired serology, and if you have an increase of titers within a certain period, you know there has been an infection. You can do also do this on a routine scheme, so, and you can create this database. It can be very helpful. In broilers, use of paired serology, well, we don't have the time for that. So then you have to create your own baseline, your in-house database, and then you can see what's going on. And if you have not been vaccinated and you have no titers, well, no indication of challenge. If you have low titers, maybe circulation of vaccine or a late infection. If you have high antibodies, in many sera, you know it's an old infection. If you have high titers, so low, etc., it might be a late challenge. If you have been vaccinated and you have low titers, that's not very good. You should have some titers after vaccination, so you better check the application. If you have been vaccinated and you have a low titer and partly negative, that's completely normal for broilers. So if they've been performing well, no indication of infection. If you have a high titer, but good performance and no respiratory signs, etc., you might have an infection, but the protection was well, so no need to change. If you have high titers and IB-like symptoms or a poor performance, well, then there might be an infection. So you need to do something. Please also check for co-infections and immune suppression, because that might be the reason why there is a clinical IB problem. Well, if you are able to do the PCR, you can see which strain it is. If then you find a strain for which the vaccination program should be effective, that's an indication that maybe the application should be looked at. If you find a strain for which the vaccination program would not be sufficient, and you cannot get rid of it by cleaning and disinfection, you might have to adapt your vaccination program. So you can see you have a kind of plan how to evaluate the results. And then with your baseline, if you have a number of flocks without any response, you should be nervous. Application should be checked. If then at some point your titers go up, and you have more It's not, PCR cannot answer everything, it's serology the same. But please also check for the other pathogens. If you only look for IB, you can only find IB. We do not have ELISAs for bad climate and poor management. So a laboratory does not make a diagnosis. That's the people in the field. They have all the data. We just have the laboratory results. That's only part of reality. So in many cases you will have a diagnosis, but not in 100% of the cases. It's biology. And part of the diagnosis is troubling, and it will remain a problem. But okay, that's a fact of life. That's biology. So how to protect against IB? Well, it always starts with biosecurity. We need to control co-infections, clean feed quality and stress levels, but we also need vaccination. With vaccination, we try to keep our birds healthy against clinical disease and against subclinical damage like combinations. We try to limit we also try to protect against transmission, and that the virus spreads to another bird, but certainly to another house or another farm. And we also try to protect against drift, that we are not creating our own field stream. But in general, what can vaccination program do? This is an overview of a meta-analysis. So in this analysis we put in all the data from 18 experiments with 137 groups with all kinds of different IB strains. And we saw that with a homologous vaccination, so that the field strain and the vaccine are very close, and you have a good application, you can expect a very high level of protection. And the average was 97%. When you use a different vaccine from the field strain, single one, heterologous, the average level of cross protection was 53%. So it's not zero, but it might be close to zero, but it might also be almost 100%. There is a lot of variation in level of cross protection if you use a different vaccine compared to the field strain. And part of that is that we type strains based on genotype, genetic differences, but the relevance of genetic differences to biological differences, that's not the same thing. We have seen that in general, when the field strain and the vaccine are in the same type, on average you have a high level of cross protection, but not always. Sometimes a few percent genetic changes, so you're still the same genotype, the protection can drop from 90% to 60 or 70. Sometimes you have big genetic changes, up to 30% difference, and still have 90% cross protection, or 10. The biological relevance of genetic changes is decided by the bird and not by the PCR in the machine. And so we should be aware of that. On the other hand, you might have different genotypes and still have good cross protection. That comes because you have little spots on the virus that induce neutralizing antibodies, these epitopes. Different types of IB can have same epitopes. So you have ones that may be different from each other, but also ones that are still in common. And this percentage of different epitopes that are in common can differ between different types of IB. So sometimes you get a higher level of cross protection just by a single vaccine. The bird decides, not speculation by the human. In general, if you use a smart combination of IB vaccines, you can induce high levels of protection against all the strains. And the average of two strains was 75% cross protection, but it can also be 90 to 100. So, by using the smart combination of IV vaccines, with the live vaccines, we have two major systems. The first vaccine in the hatchery, and the second at day 14, or, for example, already combined in the hatchery. And if you have a suitable combination, the hatchery vaccination is generally more reliable than in the field. So this is used more and more in the world. So in young birds, we know that the homologous vaccination can induce very high levels of protection against its own strain, but we have far more genotypes than vaccines. For the genotypes for which we do not have a homologous vaccine, you can use the broad cross protection by using smart combinations of vaccines. So happily, not every variant needs its own vaccine.
For me, another general rule, please try to keep it simple. Sometimes you see vaccination programs already with 4 or 5 different respiratory strains in the first 1 to 2 weeks of drugs. This is, for me, creating a headache, interference, growing reactions. Try to keep it simple. And it's a simple word, a young word. Don't over-stimulate the word. Layers and breeders. Then we need a long-lasting protection, not just for 6 weeks or 4 or 5 weeks, but let's say up to, well, in the layers up to 100 weeks, 110 weeks. So you don't find a lot of papers about protection in layers. You trying to push the wrong button or no? Therefore, we know that live vaccines you have an excellent low protection. Not long-lasting, very good for brothers, but for layers we need more. So we also have the inactivated vaccines. They are not good for low protection, but if used after live vaccine, they can really extend the protection for a long time. And this is a very nice paper, basically already quite old, but it's still a gold standard paper. These were the vaccinations and layers, different programs, but in the end, they looked at the individual level of antibodies against the challenge strain, and as you can see, if the bird has a higher level of antibodies against this challenge strain, you get a lower troponin production. So for layers and breeders, more antibodies against the field strain is better. It's a clear relation. Not in brothers, and layers and breeders, yes. So we know that for getting high levels of antibodies, we need good live priming and then an inactivated vaccine. So that's highly recommended to use certainly also in the Middle East. In general, we also know that in a good quality vaccine, and you can add a second antigen, you might even get more cross protection against more strains. But it's not as simple that you can say that a vaccine with one strain is less effective than one with 2 strains, because it's also the quality of the antigen and adjuvant. There are many more factors for the quality of the vaccine than just the number of antigens. But in the end, whatever kind of vaccine you use, please realize that the efficacy also depends on the last second. That is the deal with the full dose really going in the right place in the chicken or only on paper. If you look at the response after vaccination by inactivated vaccine under field conditions, when the people have to work hard in bad conditions and they are not well paid and not appreciated, but they have to do the real job, you see that the percentage of birds that is missed might be 1-2%, it might be 10, 20, 30%. It's really, these people should be, they should be in such a condition that they can do a good job. And the best price, the best vaccine, in the last second the bird doesn't get it. That's a waste of money. And so for protecting layers and breeders, we need maternal antibodies to prevent false layers better response to the same vaccine. And that should make us think, because these birds are not more intelligent, but they have been vaccinated with more attention, especially the brothers. We try to vaccinate the brothers in such a way that we don't get the vaccine reaction, but without the vaccine reaction, why would the bird respond? There has to be some damage. The percentage of flocks that did not respond to the vaccination at all was significantly highest in the brothers. So some vaccine reaction is needed. It's not a disease, it's essential. It has to be under control, but it has to be some damage. We saw that when the ventilation was shut off during the spray, the average response was 15.5% better. Logical, because the vaccine is not blowing out of the house. But the light was on during spray, on average 41% better response. People tend to vaccinate in the dark, because then the birds don't walk away. Yes, but they're also asleep and with their eyes shut and not breathing that much. If the second vaccination, this was around 2 weeks of age, was done within 2 weeks after the hatchery vaccination, every day earlier was 2.5% less response. If the first vaccine is not yet gone, it's still occupying part of the cells, you still have interference, etc. You make it more difficult for the second vaccine to really do a good job. We also saw that when cold water was used to reconstitute the vaccine and to spray, and cold water, it varied from 6 degrees to 18, so 18 is not warm. Every degree colder was 3% better response. And in general, live vaccines, lower temperatures help to keep stability. It's always better, except for Marex. Marex, that's in live cells, then you don't deal with low temperatures, but for live vaccines, cold water is cheap, use it please. Also in the hatchery, a very nice experiment from Professor Ryan Jordan from Georgia, University of Georgia in Athens, and he looked at the influence of the volume of the spray device in the hatchery, and when he used 7 mL per box of 100 chicks, only 1% of the vaccine that left the nozzle was reaching the bird level. The other 99% were, well, in the air somewhere. When they used 21 mL per box, 24% of the vaccine was detected at bird level. That's 24 times more than that 7 mL. So I would say you have invested in the vaccine, please use it in a way that the birds can get in touch with the vaccine. Another 1972, there will not be a lot of people in this audience which were already thinking about chicken in 1972, and still this is a very, for me, a great paper, because the vaccines and the virus are still the same. Again, you see with different tigers that with cold water, tigers were more stable than with water of 22 degrees Celsius. And if pure ultra-clean water was used, you don't have that in your poultry houses. The stability of the vaccine was much less. If there were some proteins or some salts in the water, the vaccine is more stable. Please, IP is not a fish, it's a virus. A virus that likes to be in epithelium and in mucus, and that's proteins and salts, that's not pure water. So some protectants in water help to keep an IV vaccine more stable, and not just IV, by the way. So application of IV vaccines in general, it's a respiratory virus. So the respiratory application is the preferred way. And for that, the hatchery is in much more controlled conditions than in the field. If you can do a good quality core spray, that's the first choice. We know for all the birds we can even use fine spray. But if this is not possible, a drinking water application can work as well, if you do it the right way. And sometimes people do it because they think it's more easy than spray, and then they make a mistake. Cleaning the system and the whole thing, it's a lot of work, but then it can work fine. And please realize that ultra-clean water is not good. You better add something to protect it, and it should be no sanitizers anyway. But please consider to use a stabilizer. And then in the end, on paper it's all well, but if you check, that might be, well, I would recommend it highly. If you go for vaccination and products, and we know that if you apply the vaccines and actually, even in the field, antibody responses can be very low. They can remain ELISA negative and still have an excellent protection, because the protection is mainly IgA. So serology is not good to check the intake of IV vaccines in products. For layers and leaders it works very well, and then it's the best. So you need a different approach. And for that, I mentioned the genotype-specific vaccines for ID. If you use, for the vaccines that use genotype-specific PCR around, let's say, 5-6 days after application, just a pharyngeal swab, they should be positive for the vaccine. Well, here we checked 60 flocks, and we saw that in 83% of all flocks we found all 3 vaccines, and only we had a few bad cases, but it's a very good way to check the intake of vaccines after a live vaccine. And so, final slide. Control of enemy. You have to know and respect your enemy. So with monitoring, you know which strains are in your area or in your flock. With monitoring, you can also check the intake of the vaccines so that you really know what you're doing. And because we know the vaccines can do a good job, but really have to take care of the application. And in that case, we get higher levels of protection and also earlier. Get less blowing reactions and interference with other vaccines like Newcastle, and need less antibiotics. Well, it's good for everything, and also for your profits. And that's why very important as well. So, with that, I would like to thank you for your attention.
Questions? We have a few questions to. Yes.
Thank you very much. It's really very nice that you've taken the time and benefits for your lectures. I have 2 questions or some comment I need to will about the timing using real-time PCR for the IPV. Observation when I'm using 2 different types or 2 of kits for the typing, it will mislead. The same template, the same sample give 2 different typing. I think it's depending upon the primer set each kit, so we cannot depend upon this typing to take a decision to change the vaccines or what else. Okay? Right?
Yeah, if genotype-specific PCR, then you try to develop a PCR that is able to detect all strains of that genotype. So, and if you have the right primer set, you can detect all the strains of that genotype and no other strain, then you have a genotype-specific PCR. But this also means you cannot discriminate strains within this same genotype anymore. So if you have used a variant, so let's say a QX vaccine, and you find that you have 3 weeks later a QX PCR positive, with this PCR you cannot say it's vaccine or field strain, it could be one of the 2. Then you need sequencing.
Yes, because when I go through the sequencing, I know the books are the same, but it is recombinant virus.
But
Second, about the injection technology and relation to the protection. I think if we can determine the specific mutation, if it is in the antigenic site, especially the neutralizable antibody neutralizable sites, so we can expect this can affect the protection or not. Again, if we can detect the position of the mutation is S1 protein, especially if it is happened in the neutralizable antibody sites. So we can give some idea about this can stay on the or not.
Yes, I know, and some molecular biologists are very enthusiastic in interpretation, the relevance of specific mutations into biological relevance, but in the end, it's speculation without any proof. So in the end, please ask the word for confirmation, because they are in charge, and not the fantasy or computer programs, that they have not been properly, without checking, my speculations are always true, and it should be modest with it. Thank you.
My request to all the attendees to make the most out of the time. Please keep your questions short and crisp. Should you have any further questions, please write it down on the notepad provided. We will be collecting it after the session and we will make sure these are answered. We will be only taking 3 questions per session. Thank you so much.
Thank you, Jack. Just one question regarding CT, after real-time CT, and now we have to go to the second step, which is sequencing. What is your advice and level of CT to be really close to the sequences? Because sometimes we can see that CT is high and people are sending samples and it comes negative. And the second vaccination. You mentioned 2 weeks. Please just make it clear that because it's very important, because we are repeating the vaccines every 5 days or 3 days. Thank you.
In general, for sequencing, you need more genetic material than for the PCR itself. So, a very general rule, if the CT is below 30, 32, quite often you can also do a good sequence. Not always, and sometimes you have 35 and sequence is still working, but then you need to be lucky. So in general, low in the 30s, and then you can do it, but not higher. Regarding the vaccination, let's say the second week vaccination, or the revaccination, in general, when you apply a certain vaccine in a good way in the hatchery, it takes time. And to have a good response to the second vaccination, ideally there should be 40 days or more in between. If you do it earlier, you can have a lower efficacy or even neutralization sometimes. If the quality of the first vaccination is not good in hatchery, then a revaccination can be helpful, but for the wrong reason. I would say first check the quality of the application in the field, in hatchery. If that's good, don't try to revaccinate too early because your efficacy goes down.
I confident. In some of IB what you mentioned IBV viruses, and it has not that IB shows host specificity. So the question, it has significant for chickens, the IBV viruses. This is number 1. Number 2, and the last question, it is very difficult for vaccine companies to develop vector IB vaccine. Can you just give hint in some reasons why it is difficult to develop a vector vaccine for IB?
In general, IB is always on the move. We saw in 2016, let's say a certain number of lineages and genotypes. Now we are 8 years further and we have at least 4 more lineages and 3 more genotypes. So a vaccine company, by definition, is running behind new flu strains. You cannot keep up. So by the time your vaccine might be ready, you have another flu strain. So vaccine companies cannot invest in vaccines for every time. It's impossible. And even if it would be possible, you cannot put 5, 6, and if you have 5 flu strains in the Middle East, you cannot put 5 vaccines in one day on bird. That's impossible. You have to make choices. You need smart combinations, not just bigger combinations. And I'm sorry about the first question. Basically, based on time,
I think like viruses. You mentioned in your videos, IBV like viruses. So, you know that it shows positive specificity, IBV. Chickens are the only species that are infected by IBV. So, the information that you mentioned about IBV virus-like, does that make any significance for chicken? For sure it will broaden the parasitic markets, but is it of significance for chickens?
in general, if you look for all the different types of IB, we know a few strains which are completely different than we know anything from IB, so most likely they are come from another bird species. Other bird species, like ducks and geese, they have a lot of coronaviruses, but they are not, chickens are not susceptible for that. But that can change tomorrow. There can always be a new strain which, if you put on the right bird, David Swing is going to talk about influenza, the right bird markers. That's an excellent opportunity for virus to adapt to another bird species. So if you put a lot of infected ducks and geese and whatever between chickens, day after day after day, this could result in a new type of IB. It's a matter of time in that case. Whether it will really happen, that's coincidence, but that's the other conditions that are helping the virus to adapt, and we should avoid that.
In case of reactive breeders, if you have a problem that the loss will reach to the production, peak of production, and you suspect this is false layer, is it test to confirm that it's false layer or early change of IB?
There is no test. There's no laboratory test that you can do. The only thing that really works is doing post-mortems on the right birds. That means you have to go into the house around, let's say, 2 hours before the lights go on. You select 500 birds. You feel whether you can feel an egg in the cloaca or close to the cloaca. If you feel an egg, it's not a false layer. If you feel no egg, you put this bird aside. You do that the second night, the third night, so the birds that don't have an egg, but they look very active. These are suspected false layers. Then you do a post-mortem on these birds, and if these birds show very active ovaries, they are fully alay, except there is no egg, or you see the penguin-like object, then you have made a diagnosis. So no laboratory test, you need a proper post-mortem.
Can confirm this issue? No test can confirm this?
No. The infection is already half a year earlier, so you cannot find the virus anymore. And even if you find the virus at 24 weeks, you do not know whether it's maybe 2 weeks old, it's not 24 weeks old. So, no laboratory test. Segmented genome pathogenicity, etc. But the second segment encodes VP1, the polymerase. It's kind of the engine of the replication, so it's also part of pathogenicity, but we'll come back to that later. Whatever virus it is, it's a non-enveloped virus, it can survive in your houses for several months. So good cleaning and disinfection is really important to get rid of it. Well, the virus, why is a disease for young birds? Well, because it attacks the immature B cells in the macrophages, and well, these are especially abundant in the very young birds. It also affects the T cell function, and so it really attacks the immune system. The birds really get sick by the response of the immune system. It's kind of overreaction. The damage to the birds is, well, it can be tragic for a number of weeks, but depending on the age of infection, pathogenicity of the strain, it might also be lifelong. So early infections are the most damaging infections for the immune system. And that's why the maternal antibodies are so important. They should protect your birds in the first few weeks of life when the immune system is most vulnerable. The damage by Gaboro infections, like with IB, depend on many factors: age, kind of bird, strain, level of FDAs, all the kind of immune suppression, and damage by immune suppression, and also your vaccination program. So it's not A or B, it depends on a number of variables. And if you have a clinical infection, relatively easy to recognize. It starts 3-4 days after introduction of the virus, and you can have acute mortality, which reaches a peak in 2-3 days, and then 3-4 days later it's gone. So you will recognize birds in acute phase. A bigger problem are the subclinical infections, because you don't see them. They happen, and your birds, well, they just go on. But in the end, you might have a poor performance. It might be that your daily growth is lower. It might be that your feed conversion is not good. You might have problems due to immune suppression. For example, leading to more vaccine reactions or lower efficacy of vaccines. And this is not specific. So this could all be, well, there might be 100 reasons why you have this. One of them might be the one. So you need good diagnostics to be able to find the cause of this subclinical infection. Well, regarding Gaboro, what could be subclinical infections? Well, one of them is very early infections. And the highest mortality by Gaboro is when you have an infection between 3 and 8 weeks of life. If you put the same virus in lovely old chicks, they have a tremendous immune suppression, but very low mortality. You can also have that the virus is able to cause troubles, but the birds don't show it that much. Layers give much more clinical signs than broilers, and especially the moderate common loss. If you put a virus, if I put my virus, my challenge virus in 4-week-old white layers, 100% mortality. If I put the same virus in brown layers of the same age, protection, 30% mortality. If I put them in a slow-growing broiler, or the old-fashioned broiler, 10%, 15%, 20% mortality. If I put it now in a modern Russell cup, severe immune suppression, but mortality in important experiments, 0. The modern bird shows far less clinical signs than the old-fashioned bird. But the immune suppression is still the same. You might have a variant, and the American variants are known to cause severe immune suppression but no mortality. You might have some of the new genotypes, I'm coming back to that, and you might have a real solid early Gomorrah makes the bird more susceptible to coli. Whether it's hypergenics, high valence coli, or a more normal coli, mortality went up when the birds were immune suppressed by Gomorrah. This is, it also affects the level of Campylobacter in the Sjaak. Well, it's not a problem to the bird, but for the humans that eat these products, you might be contaminated with Campylobacter. So Gomorrah also increases the risk of problems with the consumers. With Gomorrah immunosuppression, you have more risk for necrotic enteritis. You have a low with immunosuppression because of Gomorrah. You have a lower efficacy of your IVV vaccination program. Sorry? Yeah. With immunosuppression, early immunosuppression by Gomorrah, you have a lower efficacy of the Newcastle vaccination program. And with early immunosuppression and then Newcastle vaccination, efficacy was 35% instead of the 90 to 100% efficacy of the Newcastle vaccination when there was no immunosuppression. So, immunosuppression can be really damaging your birds. So, we need to detect them. If you would like to detect a norovirus, then you have two main ways. You go for the virus, or you go for the antibodies. If you go for the virus, again, PCR is the most used system. To find the virus in case of an acute infection, that's very easy. If you have this kind of Bursal, and you put a swab or whatever, you put this in the PCR, you will be able to find the virus and sequence. And CTs will be very confident and high, or low levels, there'll be a lot of virus, you can find it. The problem is that the subclinical infections, you don't know when the person was infected. You might just be 3 weeks after infection when you have a problem. You see small Bursal, and then what? So you need multiple samples. If you have no acute clinical signs, but your flocks are not performing well, that might be due to the bottle, but you don't know when to sample, so you have to sample every week. If you sample in 2 weeks, 3 weeks, 4 weeks, 5 weeks, you can send the samples to the laboratory immediately. You can also put them in your freezer. And then if the flock has been performing very well, you don't need the Gomorrah diagnostics anymore. You throw your Bursal away. But if again your flock has not been performing well, please get the Bursal out of the freezer, send it to a laboratory for Gomorrah testing. And then, well, if you have this kind of sampling, you should be able to find the field strain and type it. Now this typing, different typing systems happen. If you look for the main protein for typing, it's always been VP2, that the outside protein with all the neutralizing epitopes, that decides a lot of pathogenicity. But now, I come back to this later, you also have to include VP1. When I started, when I was a young vet, it's quite some time ago, but then we were talking about two kinds of strains, the more or less classical-like strains, which they all cause an inflammation of the Bursal. So it's getting bigger with your edema, and then you get your atrophy. Let's say after 7 to 10 days you have a small Bursal, but the risk first is increased. The second group is more the American-like variants, which do not cause inflammation, but atrophy right away. So you don't get this smaller Bursal, you get a small Bursal. It's too simple, but that was the start. I guess standard paper from, well, not that old, 2018, was from Sjaak, in which Gomorrah strains were divided over 7 different genotypes, so genome groups, with different subclades, and then the very virulent virus was genome group 3, the American variants were genome group 2, the classical most vaccines were in genome group 1, and then we had some smaller, at that time maybe not it's already in the Middle East for a longer time, and part of your detections are genotype 4 at the moment. Another one is genotype 6, which is called after an Italian strain, Italian-like. But if you look at one of the older sequences, Kingdom of Saudi Arabia, and this is one also at the present one of your major field strains. And if you then go back to genotype 4, and this is a publication from some time ago, a very good one, in which they compared the pathogenicity and antigenicity of this strain compared to the old-fashioned very virulent field strain. And as you might see here, no mortality by this genotype 4, no clinical signs, and it's very small measure. So, no mortality by genotype 4, but severe bursal damage. They also looked a little bit at the antigenicity, and part of the neutralizing monoclonal antibodies that recognize the old-fashioned field strains do not recognize this genotype 4. So, it could be that the maternal antibodies derived by classic vaccines might not be so protective for such a long time as against the old-fashioned field strains. So you might have earlier breaks. They also looked at the level of immune suppression using the Newcastle model. So they gave 2 of these strains to 1-day-old SPF birds. Well, you don't have them in the field, but just to show what the virus can do. Then they vaccinated in Newcastle, and then they challenged with the velogenic Newcastle. And as you can see, the antibody responses in HIV test after the vaccine were much, much lower than without immune suppression by this strain. And the level of protection against challenge with the velogenic strain was not 100%, but only 44 or 70%. And so genotype 4 is immune suppressive. Genotype 6, one of your other field strains that you have, they put this experiment in SPF birds, no mortality, no clinical signs, but severe atrophy of the bursa. And just as if you focus for the 40-day-old birds, these were birds that had not been infected, so you see very nice follicles, a lot of B and T cells, happy bird. These were the results of the genotype 6 challenge. No follicles anymore, no signs of recovery, so it's an immune suppressive virus. That was all typing based on VB2 and relevant experiments with birds, but we have a new development lately from last year. As I mentioned, VB2 outside protein is very important, but it's not the only important protein in the virus, because the VB1, the other segment of the RNA, is also part of pathogenicity. And in the old days, they always assumed if I know VB1, I also know VB1 because that's a fixed combination. That's simple. And you can have recombinations so that the outside of the virus is strain A and the inside, the polymerase, is of another strain. Now, if you look at the literature, there are very nice papers from US and several European groups in which they detected recombinants. Some of them had still high mortality, but most of them had a lower mortality compared to the old-fashioned very virulent field strains. And because on average, the outside protein is still very virulent, but the VB1 is from another strain. Now this was very nice papers, but what about prevalence in the field? Now, before going that, this is the new gold standard for tagging of Carbonara strains. Everyone can use VB2 and VB1 for tagging, and then VP2, let's say the outside protein, has now already 10 main groups, and the VP1 gene has 5 main groups. So you can have different combinations of A and B, like H5N1 or H9N2. You can have an A and a B code. In the meanwhile, for detailed information, you still need the sequence of VP2. So for that, nothing changes. So these are the A segment subtypes, A0 to A9, and the B has the B1 to B5. But it's all random combinations. There are highly preferred combinations. This was until rather recently. Many of the A segments, when you were serotype 2 or a classical vaccine or an American variant, your gene group 4 or 6, they all had the same B1 classical VP1. Only the very virulent virus had its own B2. So that was a fixed combination. And then you had some minor groups. Well, that has changed, at least in Europe. And this has expanded so fast that I would not be surprised if it turns up in the Middle East at some point as well. This was a paper from Italy in which they looked at 470 flocks in Europe without clinical signs of corona, just routine sampling. Also detected vaccine strains and a new virus, but 25 of these so-called healthy flocks had a real assortment of the very virulent virus. And the VP1 is from a cell culture vaccine, like strain. So, in Europe, at the moment, this new combination, A3 outside very virulent, but inside B1, has become very dominant in a few years. Just to show some Dutch results, and we found until 2014-15 only the, let's say, the old-fashioned virulent strain, and then suddenly, in 1 year time, all strains, 100% of field strains were 4 mutations further, and a reassortment of the VP1. And since 2016, we have not detected the very virulent virus old-fashioned strain anymore. Not just in the Netherlands, but in a big part of Europe. We put this virus, on the outside of VP2, there were 4 mutations, which one of them also lowers the pathogenicity, but the extra factor is the new VP1. So there are 2 major changes in this virus. We put this virus in SPF layers and SPF borders. SPF borders show nothing at all. They eat and drink like normal. The SPF layers, okay, they had a few days that they were not fully happy, but that's it, no mortality. But the old-fashioned field strain, 100% mortality. So a big change. But the Bursal damage, almost max. And even after 21 days after infection, no sign of recovery at all. Well, this is something again that this is really an immune suppressive virus. And so, which strain you have in any area, and like the gene group 4 or 6 in the Middle East, or this reassortment virus in Europe, you don't see the infection. You just see the results of maybe immune suppression. So, if you want to be able to find this strain, you have to have an organized way of sampling. Because they might be able to break through earlier than you're used to. We do know that the early infections are the most damaging. But you underestimate the process because you don't see the mortality. But if you sample every few weeks, 2, 3, 4 weeks, 5 weeks, and you send for testing, you will find the virus. ELISA is also able to detect the infections, but ELISA is not able to discriminate between strains. It's coronavirus infections which are the most damaging. If you have a variant or a field strain for which the antibodies by the breeder program are giving good protection in your MDAs, you're safe. If at some point you get very early breaks in the presence of high MDAs, this means that you might have to adapt the breeder vaccination program with the second strain in the program to get more MDAs against your field strains. But that field will tell you. After MDAs, active immunity has to take over. We have different kinds of vaccines available, and conventional live vaccines that you put in the drinking water, the immune complex vaccines, and recombinant vaccines, and mainly for boosting inactivated vaccines. But we know that this is a nice thing of tomorrow. If a Gabor strain is replicating in the Bursal already for 1-2 days, you already get what we call viral competition. Then the results of the field infection will already be a lot lower. So you don't have immunity after a few days, but you can have already partial protection against damage by this early replication of a Gabor strain. This is a very nice paper from the US, in which they show that if they applied the vaccine 16 hours, 24 hours earlier than the field strain, already mortality and person damage was lower. So this viral interference is working well for everyone. But you have the live attenuated vaccines that can do an excellent job. But you have to apply them after the NDAs are, they have to be lower. Different levels of attenuation. Well, less attenuation means you can vaccinate earlier, but you might also have more person damage. So you have to find a balance what's good for you. If they start replicating, you have this viral interference, and after 7 to 10 days you have full immunity. They spread, so that's good. And if birds are missed, or they are utilized the vaccine, you get it from normal. But if you apply them too early, many birds will utilize the vaccine and it's lost. Immune complex vaccine, you can apply them in ovo or in hatchery, or a day of hatch. These vaccine strains are on average immediate plus of hot, so effective, but maybe for broilers. For layers, they are not considered to be safe. So most of these vaccines are not suitable for layers. Now, they start to replicate not immediately after application, but when the MDAs have gone down to a certain level. And in the field conditions, replication often starts between 2.5 and 4 weeks. So not earlier. But they are normal vaccines, so they spread, and you get a very broad response. The recombinant vaccines, basically HPV, VP2, again, in ovo or applied at day 1, they start to replicate immediately after application. It's an Arabic strain. So independently of the derived antibodies, and they can give full protection, but not in a number of days. They take more time. So they do not spread. So if a bird is missed in the hatchery, it will not get the vaccine from one. It will be unprotected. And in general, HPV vaccines don't combine them. You have to make a choice. So a lot of programs which can all do a good job. It really depends on many factors what might be best for you. And one of them is reliability of application. If you consider the application in the field as not reliable, please go for hatchery by definition. Hatchery vaccination is more under control. In the field, you have to know, or have to consider the level of derived antibodies and the variation, field pressure, and want more vaccination, so it's more complex. It can do an provide live vaccines based on serology, and 100% good response in all flocks by PCR, by serology, by stock. It's very good. However, when they applied vaccines just, well, let's do it on 80 days because it's convenient. Part of the flocks were vaccinated too early, some too late, and when they then checked the take of the vaccine, they saw that in all flocks, when the vaccine was applied earlier than the level of NDAs allowed, they had no or slow, very slow take of the vaccine. So these vaccines can do an excellent job, but the timing you have to take care of that. That's in the right order. So again, like IB, like any disease, checking and monitoring gives you much more information. And with information, you can have you can have good decisions. If you look for example, if you have your baselines again, and you look for the level of antibodies and the variation, percentage of positives, you can have a very nice indication what's going on in the field. And if you use a vaccine for which you expect an antibody response and you measure nothing, then you have to go into the details of what might be wrong. And if at some point titers go up, you get more very high titers, that's an indication of field challenge, and then PCR can help you to see which strain is involved. So, we know that corona vaccines can do an excellent job and still we have outbreaks. Well, one reason might be a very early high field pressure. If you have an infected flock and the cleaning and disinfection is not good, and there's too much virus waiting for your day-old chick, any vaccination is too late. Don't blame the vaccine. It's the cleaning disinfection that's not good. It might also be that you have a new field strain for which the maternal antibodies are not as effective as you expect. And if this happens several times and you can connect it with a certain new strain, this might mean you have to adapt your breeder vaccination program. Might also be that the timing, especially in the field of your field vaccination, is not good, certainly too early, and then you get lower efficacy, so more outbreaks. Or is the application, and that can also be an hatchery that it doesn't go in the right way. Checking with PCR and serology is very easy. Checking the efficacy of cleaning disinfection is difficult. You can use the agar gel for bacteria, but depending where you put it, it's only for easy growing bacteria. That's not saying a lot. And the resistant viruses like Ebola and Chikungunya, Marix, the rotavirus, astroviruses, reoviruses, they are much stronger than coli, etc. So checking for bacteria and your clean house doesn't say a lot. Checking for these viruses would be much more informative. But you cannot do this by PCR all day long because PCR cannot discriminate live from inactivated viruses, so it's not useful. So that's why we use, we call it the fit check. We check for enteric resistant viruses at about 5-6 days of age. So basically we use the chick as a PCR machine. If the viruses are waiting, I can assure you in your houses, if you check at different ages, you will always find astroviruses, rotaviruses, reoviruses in your flocks. They are happy, they are healthy, but I'm sure they all have these viruses. So without proper cleaning disinfection, your next flock will get the same viruses. If your cleaning disinfection has been very good, they might be delayed for a long time, maybe to even get it. Without proper cleaning disinfection, they will get it at day 1. Now, we measure the amount of virus. 5 of these resistant viruses with high prevalence around 5 days, 6 days of age. And then we give it a score, and you can see that houses If you're in red or orange, you can be sure that the rotavirus can survive the same process. It will be waiting for you in day one. So try to get into the green. And so to conclude, in the Middle East, I know you still find the old-fashioned very virus, but also genogroup 4 and 6, which do not cause mortality. So you might underestimate the presence of this virus. So if you don't check it at the kind of monitoring program in these suspected farms, well, you might find viruses that you don't expect. And we do know that if the feed pressure and day one is too high, any vaccination program will fail. And it's always the combination of vaccination and biosecurity, proper cleaning, disinfection. Every other factor that you add, risk factor, half dose or being in a hurry or whatever, increases the risk for outbreaks. Please check the quality of the vaccination procedure in time. So not like in the Netherlands, we do nothing and still we have a problem. Then we start checking, find it, solve it, and then we should have been checking before. I hope you do better than in my country. And please, but it's an open door, vaccination, extra tool, in addition to biosecurity, cleaning, disinfection, and good management. And then it's an excellent tool that keeps your bird healthy. And with that, I would like to thank you for your attention.
So, questions, please.
Hi, Sjaak again. Just we go for PCR, the sampling. There are people are sending sampling from dead bears. From the dead bears. I take samples from the dead bears to send it to check the PCR. Is this correct? The second question is, when I can take samples to check the vaccine application, the PCR, for PCR. After 1 day, 10 days, I need to know exactly when I take the samples to be sure about the result. Thank you.
In general, sampling dead birds for PCR testing, certainly RNA viruses, is not. It would be fresh birds, selected birds based on clinical science are the best. If a bird is dead, it starts to well, it's 40, 42 degrees, very fast, and also then RNA goes down, everything goes down. So fresh, selected birds are by far the best samples to take. When you, depending on if you have an HVT vector vaccine, okay, then that's more. Then you don't check for the body, you check for the presence of HVT in the spleen or the feather bone. So that's a different. But if you check the replication of the immune complex of the live vaccines, and when these vaccines start to replicate in the individual bird, after 3-4 days, you have the highest amount of virus in the liver. So theoretically, if you would apply a live vaccine in the field and you would sample birds, let's say 4 or 5 days later, by PCR, or you also have this lateral flow test, you can expect that the birds should be positive. The other way is to check by serology. In general, ELISAs are becoming positive after a good take of the vaccine. Depends a little bit. If you take BioCheck, after 7 days you can already see the immune response. With IDEX it takes a few days longer. But let's say 40 days after the application of a live vaccine, you should see a clear response in the ELISA, whichever producer you use, IDFED or IDEX or BioCheck, whatever. So these are the two main ways to check it.
Thank you, Dr. Sjaak. I have a question regarding the vaccination with vector vaccine against Ebola disease. Recently, we noticed that there is some failure, some big projects due to the usage of vector vaccines, and actually they claim that this is related to the variant strain of IBD
To start with the easy part, the last part. If you have a certain vaccination program based on the hatchery vaccination, but on specific farms you have breaks or more complicated situation, you can always combine it with another kind of mode of vaccination. So if it's needed, do it. It has no negative effect at all, it can only help. That's the easy part. Now, breaks in the HVT vaccinated flocks, that's a bit of a, that's more complicated. In general, if you have an immune complex vaccine or a live attenuated vaccines, they spread. So if you miss a bird, not important, they will get it. Not with HVT. HVT does not spread from chicken to chicken. So if 5% does not respond to the hatchery, you have 5% susceptible birds. But in the first few flocks you will not see it, but it gives the opportunity to the field straight to build up, and at some point you might have to see problems. So it could be that the percentage of birds that is responding well to the HPV vaccination might not be as good as you hope for. That's one part of the explanation. The other part is for me an unknown part, and that is and this is a bit tricky to say, but okay. If you look for science, that's the same answer. If you look for animal experiments with vaccines and field strains, you find a lot of experiments, a lot of scientific papers with the classical vaccines or immune complex vaccines, and then with a number of variants of field strains. And you find high levels of cross protection, no problem. For HVT vaccines and protection against non-classical strains, the number of scientific papers is very thin. And I know there are claims from companies that say there's a broad protection, but how broad? If you have tested one variant, what does that say about the second variant? As a scientist, I think there is a lack of science of the level of the time that's needed by vector vaccines to achieve a good level of cross protection against different strains. It could be perfect, but I cannot show you. I would love that I could show you and say, don't worry, but I'm not able to do that. Sorry.
In the middle of the study, you mentioned about using the mild vaccine before challenge by 16 to 24 hours. It's applicable to use when I have a challenge in one house. I can vaccinate in the other houses. It will be helpful.
Yeah, if you look at it, I showed you one paper, but there's for another paper for example, from Della Jackwood, in which he gave an American variant virus 2 days ahead of any different virus, the same. And we have done it at GD as well. It's not yet published, it's submitted. This viral interference works. It really helps. So if you would have an outbreak in a certain house, vaccination is useless. The field strain is already there. But if you have other houses, which you think, hey, maybe you can certainly try to vaccinate them as a kind of emergency, because if, I don't know, 10, 20, 40% of the birds are already susceptible for this vaccine, it helps to lower the damage if it goes to other houses. But then, again, it's not actually vaccination, it's a vaccination. And then preferably with a strain that has a higher rate of titer, because with a higher rate of titer you can vaccinate a higher percentage of the birds at the time that you need.
Thank you, Poultry. Yet again, regarding the winter formula. The winter formula, I think, developed 20 years ago. For the Middle East circumstances, it is very difficult to use it. For example, if you wait to 20 days, 22 or 23 days for the first prime vaccination, by that time the problem will be passed. Yes, really we use other formulae. It ranges between 16 to 15. The same zero sample, if you run it at the winter, this formula to suit the Middle East circumstances?
The data formula is based on making sense of levels of maternal antibodies and the variation in it, and it has been developed a long time ago. It's developed for classical vaccines against antibodies derived from a classical vaccination program. And that's a big part in the world where this is the case. At that time point, we found, well, for example, half-life times of 3 days, 3.0 days in broilers. At time we think broilers are growing much faster than in the past, so the half-life time should be lower. Well, a few years ago we determined it again for the Ross and Culp, etc. We found 2.9 days. So at this level, I think the level of change is very limited. What has changed for that part is the field strains. And if you have a variant-like strain that breaks through the NDAs much earlier than the strains that we know, then any vaccination based on serology is you're too late. But that's not a mistake of the formula, that's a change of field strain. At the same time, you have to choose, it has been developed in a certain ELISA from one company. It has been compared with other companies, but sometimes other companies they use a different breakthrough titers, or they have a different titer on the same serum. And if you have one serum, you send it to 4 different ELISAs, you can have 4 different titers. But in reality, it has been validated for one, and I know there is a general good correlation with other ELISAs, but not with everyone. There are a few ELISAs that I beg you not to use for level of NDA determination and doing something with it, because they are developed for another purpose. So, to make a long story short, I still think that the data formula can do an excellent job if you use it in the right way. But for details, I would rather discuss this in private than to mention certain names of ELISA producers, because that's not, I'm not going to do that.
Okay, Dr. Sjaak, I have a question. Can you give more insights or comments about the subclinical Gumboro, about the kinetics, about the pathogenesis, about how to monitor to avoid, this sudden onset of disease?
Maybe I can show you with an example. If you see in Europe, we were used to the very virus. It was you cannot miss it. The birds get very sick. You do a post-mortem. You see Bursals, which even without my reading glasses, I can make a Gumboro diagnosis in an acute phase. It's simple. So you will find your virus because you're on the right thing. So Gumboro was more or less under control in Europe until 2016. At that time point, I didn't show it, but we also did a European survey, and we found only a few % of infected flocks in Europe. It was under control. A few years later, this Italian study, 25% of healthy flocks were infected with Gumboro without knowing it. It was this reassorted virus. If we then see this virus has replaced the old-fashioned strain in 1-2 years, completely gone. It's only this new strain in a high percentage of flocks. We find it much more often than in the past. But then you can ask why. It's not more pathogenic. We don't have that much very early breaks. But people underestimate the prevalence. Farmers call us, okay, you have done post-mortem and the PCR is positive. So what? Because my birds, they don't die. Why should I vaccinate? Why should I take a lot of effort in cleaning this infection when you find a virus for which I don't see mortality? That's the old-fashioned way of thinking of very virulent virus. This is an invisible enemy that you underestimate. There could be much more virus virus than you know. So why pay a lot of attention to vaccination when you don't know there is a field strain? So people tend to vaccinate less, or half dose, or less attention, etc. Perfect for the virus. It exploded in Europe. And I would not be surprised, okay, to my knowledge, you don't have to be a sword yet, but you do have genotype 4 and 6, which you don't see either. That's excellent for the virus. It's a stealth virus. It's there, but you don't see it. So you underestimate it. Maybe your clean downtime is maybe still, if someone you need a long bird, you might have, I don't know, normally 7 days, now it's maybe 4 days, or less attention to cleaning, disinfection. You are helping the virus. Please do not underestimate the relevance of immune suppression. If the conditions in the field are perfect, immune suppression is not a problem. If you don't need an immune system, if it's gone, you burst off. But when you have IB or H9 or necrotic enteritis or Clostridia or coccidiosis, Newcastle, etc., you need a full immune system. Don't underestimate immune suppression. Look for these traits.
Thank you very much, Dr. Sjaak. Okay. Yes.
Thank you so much, Professor Sjaak. With this, we conclude the first session of today. Ladies and gentlemen, hope you are having a fruitful session. Here, I would like to announce that the Zohar prayer in Riyadh today is held at 6 minutes past 12. For this reason, we will be going on a quick coffee and prayer break. We will resume exactly in 13 minutes at 12.